The Earth at night provides a view of cities and countries connected by an ever-growing dependence on a power network grid. We are working with researchers at the University of Texas at Austin to implement energy storage for the campus-wide cooling network. With over 50,000 students, UT Austin is the fifth largest single-campus enrollment in the U.S. The campus power plant produces electrical power, heating, and cooling for all of the campus needs. Focusing on the cooling system, there are a number of cooling stations on a campus network to provide cooling for the buildings. The cooling is driven by electrical compressors that can be cycled on or off depending on the building loads. We are seeking to better understand the electrical and heating loads to measure the impact that the thermal storage has on the overall plant. For example, can we save natural gas by shifting electrical loads to periods when it's more efficient to produce electricity? Energy storage in a smart grid offloads the requirements during peak demand times to times when less power or cooling is required. While the campus produces typically only 40 to 60 megawatts, it can produce 137 megawatts. It's very reliable, must produce steam, cooling, and power generation for the entire campus. Focusing on the cooling system, there are a number of chilled stations as previously mentioned. The thermal storage acts as a buffer to store the chilled water during peak daytime demand. The energy savings from this project will be equivalent to about taking 800 cars off the road each year.
So I'm working on a combined heat and power plant to do control and optimization. In this project, it's focused to optimize the overall power generation and also the cooling system at the University of Texas campus. Some of our anticipated innovations will include detailed knowledge of operating scenarios, optimization and scheduling of a CHP plant. It will also include the investment under certain economic and operational scenarios to provide quantitative plans as a result of our economic and operational forecast.